Okay, it is time to start. Welcome. This is a live session here in science. My name is Amy Defoe. I'm one of the science teachers here at Graduation Alliance, and thank you for joining. I hope you're having a good day. You can see in the background here, we've got the sunshine out. It's cold where I'm at. I'm in the eastern part of Washington state, but it's still a nice day. It's nice to see that sunshine out. So today we're going to be talking about the topic of science, and I'm going to do a little presentation on the greenhouse effect and also talk a little bit about scientific investigations, but I also broke up in this session some time for questions and answers. So if that's not a topic that you're at right now, we'll definitely have some time for you to ask questions or get any help that you need. I apologize. I thought my cold was going to be a little bit better, so bear with me if you hear little sniffles going on. I apologize. Okay, let's go ahead and get started here. A couple of things to just kind of housekeeping items to discuss. As you guys know, the videos and the sessions are recorded, and we do keep them in a great big nice library, and so you'll get the link so that you can go back and view those, which is so fantastic because life is busy and life is hard, and we've got lots of different roles and responsibilities that we're all dealing with every day, and sometimes these live session times don't work out the best. And so you can go to this library and you can take a look at all the sessions that have been done. It's also awesome because maybe you're not here at this point in time in your course, and once you get to it and you're like, oh, the greenhouse effect, you can go back into the library and you can do a quick little search. You can filter it by science, search in by topic, and you can find a session that goes over maybe a concept, a lesson, or an activity that you are working on. So please use these to help you out. And again, they're not just in science, they are in all the courses. So just didn't know that. So awesome stuff. During the session, I do love the interaction. I love the feedback. I'm not sure I understand. Sorry about that. My watch is talking to us. I apologize. What I was saying was during these sessions, I love the interaction. I love that feedback. It's great that we're able to, get our credits and do our schooling, at a time that is convenient for us. But it's also nice to have that interaction with, your classmates, your teachers. I enjoy seeing my students as well. So please, if you have questions, have feedback, want to answer questions, which I hope you do, please do so. So you can unmute yourself, make sure that your microphone is off or on so that you can talk. Make sure it's off if you got some background noise going on in the back. Hello and welcome. We're just getting started here, going over some housekeeping items. You can also use that chat function. So on your screen there's a chat box, and you can type in if you have questions. You can also type in if you want to give an answer, give some feedback. So whatever mode of communication works for you, that is wonderful. So great, thanks for joining. Let's go ahead and get started. So again, let me show you kind of just a little overview of agenda here. Like I said, I'm going to first talk about the ozone layer and the greenhouse effect. So the last couple of weeks I've been kind of moving into this, and last week as we talked about biodiversity, I brought up the whole idea about the greenhouse effect and some climate change talk. And so I want to talk a little bit more into that. And then after that, I'll open it up for questions. So here's the opportunity where if you have a question about an assignment, an activity, a lesson topic, and you would like to get that answered, get a little bit more information, that is when we'll do that. And then I'll come back and we'll talk a little bit about scientific investigations. And then, of course, before we leave, I'll end it with opening it up for questions again for you guys to make sure that you are set and ready to go in science for the rest of the week. Sounds good? Okay. You might see me popping down, my eyes looking down there. I'm looking at my chat box. I'm looking to see if we get any questions or feedback that comes in. So please make sure that, if you have questions, you have feedback, throw it out there, guys. Let's go ahead and get started. And again, if you're just joining us, sorry, you can tell I'm a little congested here, got the little start of winter cold going, so bear with me, I apologize. Okay. So we're looking at Earth Science Semester 2, but this is also, we see this in lots of different courses. Some, pretty controversial topics that we're dealing with. So maybe in like some current world problems courses that you might be having, you might see some of this type of a topic, but we also see it in environmental science, a little bit in biology, as well as we're talking about the greenhouse effect and the whole idea about climate change and global warming. So this comes from Earth Science Semester 2, and we're looking at kind of the unit in Unit 4. But again, like I said, it touches upon everything, okay? So here I have a fabulous picture. Have you guys seen these before? This is a pretty big one. Okay, that is a greenhouse. That is an example of a greenhouse, and it's a very large one, so it's probably probably like a commercial type greenhouse. So you guys know, what do we use greenhouses for? What's the idea or purpose of a greenhouse? What are they supposed to do? Why do we use them? There we go. Grow nice plants. Yes, let's hope they do, huh? Yes. So the idea is that it's a way for us to grow nice plants, as we heard, you know, make sure that we're setting up the right conditions, so to speak, for the plants to grow. We know in our daily environments that the weather changes, and sometimes, you know, it's colder and it's too cold or it's too hot. And so the idea with a greenhouse is that it's trapping in the heat, and it's providing that a nice, warm, usually kind of moist and humid environment that plants tend to thrive and grow well in. Okay. So, well, what does that mean for science? Let's go ahead and get into that. We have to think about, well, where does this heat come from? And we talk about this through all of our science courses. Where does energy come from for our planet? If you think about it, and it says right there, from the sun. So the sun is kind of like our big energy source. It helps kickstart and keep all of the cycles on Earth and systems here on Earth going. So as we think about the water cycle and photosynthesis, this is all driven by the sun. If we took the sun away, we wouldn't be here as well. Our planet would be way too cold. So it says the Earth receives 1 out of every 200 billion particles of energy emitted by the sun. Some of the energy goes elsewhere as well. So as we think about of the solar energy, so thinking about the sun being so far away from it, and that energy, those waves, energy is hitting the planet, and only about 30% of it, or it says 30% of it is reflected, or it bounces off of our Earth's atmosphere, from the clouds and the Earth's surface, and it kind of goes back into space. So as we think about it, all of these energy waves of the sun are hitting our planet, and they're getting reflected away. Why would that be? Well, we don't want too much heat. So we have this nice little balance that's created by our atmosphere. Another 25% of that energy evaporates the ocean and other surface water. Welcome back, which in our atmosphere with water vapor that will eventually rain back down on Earth. So we talked about that water cycle. Hey, thanks for joining us. We're starting off talking about the greenhouse effect, and then I'll open it up for questions here. Other solar energy, as it's stated, absorbed by plants, which you know they use sunlight to photosynthesize, make their own food. Okay. So again, think about it, the importance of that sun. We need the sun. The sun's energy provides plants with energy. Plants absorb solar energy and convert it into glucose or simple sugars. This is the process which plants convert solar energy to glucose or chemical energy. And we call that photosynthesis. Photosynthesis, okay? You hear lots about that as well, and then you go into cellular respiration. So everything is like feeding on each other. They're all connected and needed. So again, lots of reasons why we need that sunshine, okay? As we think about other ways that we need the sun, I'll just read off a few of these here. Sun provides a light source. Kind of crazy to think about it. You're like, yeah, that's the sun. You think about day and night, okay? The sun is providing us with this day and night. Simple fact, but it's pretty cool to actually think about, you know, as we're facing towards the sun and away from the sun. Heat. Solar energy naturally creates heat when it shines on physical objects. I know this morning, I walked my kiddos to school, and when we were in the shade, oh man, we were down in the teens this morning. It was cold. And then once you kind of got into the sun, it was like, oh, you warm up pretty quickly. It feels much nicer. Solar energy is also responsible for the winds that blow through the Earth's atmosphere. Causes by temperature changes, heat rises, and then it mixes with the cooler air. We also know that we get electricity or power from the sun. Solar cells, called photovoltaic PV cells, are used by scientists to convert sunlight directly into electricity, but we also know that people use them, it's becoming more and more common that people use that solar energy, which is great because it's a, more of a cleaner natural resource. And of course, vitamins. Solar energy helps humans produce vitamin D, but we also know that too much sun can be harmful for us, okay? So again, just going over some reasons why that sun is so important, okay? Now we think about it in terms of our planet. The Earth is the third planet. As we say, third is best. The Earth reflects about 30% of the sunlight that reaches the planet, okay? So here, as you think about it, here's our planet, okay? We've got the sun and we've got those rays shining down on it. We've got this nice little layer here. You guys know what that's called? It's like I got a bubble around our planet. Any ideas what that is? What that bubble is, or what that kind of pretend greenhouse is? We're going to talk a whole lot about it. Okay. Okay, well, we're talking about our atmosphere, okay? The remaining proportion of the solar energy is absorbed by the atmosphere and eventually converted to thermal energy or heat. More heat is being trapped by the Earth. So as you think about it, as these rays are coming in, we've got this protective layer, which is our atmosphere, and it's trapping that sunlight here on Earth to keep the surface of the Earth warm. Okay, so let's go over what is this greenhouse effect then? So in the atmosphere, greenhouse gases, it's a mixture of methane, carbon dioxide, and they're acting to trap that thermal energy near Earth. Climate change experts blame many human actions for the recent increase in greenhouse gases. Okay. We'll talk about what some of these greenhouses are, because an increase in fossil fuel burning for the higher energy demands, you think about it, the more people there are here on Earth, the more demands and resources that we need. And so we've got more energy needs, and so we're increased the uses of fossil fuel. We drive more, producing more carbon dioxide in the air. Most of the increase has been carbon dioxide since the Industrial Revolution. And scientists have given that kind of increase in global temperatures the name global warming. So that increase in carbon dioxide production into our atmosphere is causing temperatures to rise because it's part of these greenhouse gases. And again, they're acting like a trap. It's like they're holding on to that heat in our atmosphere instead of letting it escape. Let me show you a picture here in a second. So what are those greenhouse gases? Carbon dioxide, nitrous oxide, methane, and CFCs. These are kind of, CFCs are chlorofluorocarbons, and they're commonly seen in like aerosols. And so we usually don't, you kind of see it's like, if you look on the packaging of it, you'll probably even notice it says like no CFCs on it. Because this is one of kind of the actions that humans are taking to kind of reduce that use, is reducing the CFCs that are used. Okay, so let's take a look at what that is, what's kind of happening here. And we think about the greenhouse, we have what we call the natural greenhouse effect, and we have the human enhanced greenhouse effect on each side here of the screen. So naturally, we want to have this greenhouse effect. We want the Earth's atmosphere to trap in some of that sun's radiation, that energy, to keep us at that perfect balanced temperature. Not too cold, not too hot, right? We didn't have that atmosphere, all of the sun's radiation, their energy, would come to Earth and it would bounce right back out. With our greenhouse, with that atmosphere, as you can see, that radiation comes in, this is energy, and here it's kind of trapped. So again, we've got this greenhouse. This is in our atmosphere, and those gases are keeping some of that heat in, but allowing some of it to go out. So it's creating this natural balance that's just the perfect conditions for Earth. Now, when we add humans, and we think about, CO2, carbon dioxide, increase in fossil fuel burning, we're increasing those greenhouse gases. What do those greenhouse gases do? They trap more of that heat. So the more gases we have here, as you can see kind of by the coloring here, as that sun's radiation and energy is coming to the Earth, as it gets re-emitted or bounces back, reflected back, it gets stuck here. And those gases, now with more of the greenhouse gases there, they're trapping. It's like they're collecting on and they're holding that heat, therefore making, that it can't escape out into space. Rather, it stays here in our atmosphere and increases our temperatures. So you can see less heat is escaping into space. Okay. So again, the greenhouse effect is great because it naturally creates the perfect temperature. But when we produce too much or put too many greenhouse gases into the atmosphere, we're trapping that heat, making it warmer, less gets out. We're creating an imbalance here. Okay, so why does that matter? Maybe you're like me and you're like, I want it warmer, right? The Earth's average temperature has risen about 1.5 degrees Fahrenheit. Now, it doesn't seem like much, but when we think about how delicate Earth systems are, just the smallest little change puts everything into kind of flux. Things change, and you probably, as we go through this list, you're going to be like, yeah, I've kind of been hearing that, noticing that. Increases in overall ocean water levels are caused by the melting of polar ice caps and glaciers, and that's because that small change in temperature causes huge effects. So again, just raising it 1.5 degrees causes our ice supplies, think about glaciers, ice caps up at the poles, those are melting. If they melt because the temperature is warmer, that means it melts into the ocean and our ocean levels rise. Okay, well, then you might think, well, why does that matter? Well, it has an effect on a lot of things, and one of them is we think about habitats, organisms that live. Some organisms live, like polar bears, live in those ice areas of ice. That also increases the intensity that we see in hurricanes, typhoons, and tropical storms. Hey, welcome. We're just talking about the greenhouse effect here. So it's cascading and it's creating all of these other effects are coming from it. The good news, as we kind of talked about with CFCs, is that we're becoming more and more aware of this. And with the increases in greenhouse gases and global warming, we've also then, decreased some of the major influencers of that, like those CFCs, those chlorofluorocarbons, reducing our usage of them. We also know that, legislation and governments and other countries are all coming together and working on kind of bills and acts to help limit that use. Okay, so again, what's the evidence as we think about it in science? Well, okay, we can say this is happening, but can I really go into the atmosphere and collect all this data or see how much of the sun's radiation is coming in and going out? Kind of hard, but we can collect evidence. And what scientists do use is they measure gas levels in the atmosphere. Okay, so let's take a look at this table, this nice little graph here. And it's showing here, down at the bottom, this is years, okay? So we're talking, a long time ago, year 0, 500, 2000, so as we can think about, we're right there on the edge of that line. And then this is CO2, nitrous. These are the gases that they're measuring for, as you can tell by the colors. So that red line is measuring carbon dioxide. And so what we're looking at is how the levels change over time. So this is most recent to the past. So as we think about it, they're all pretty stable here. All three of our gases that they're measuring, scientists are measuring here, are playing, pretty simple. And then all of a sudden we get to, you know, this mark here, what, 1800 we'll say, and boom. What do you guys notice? All three of the gases, what do? Do they stay the same? Do they decrease? Do they increase? What happens to that line when we hit that 1800 mark? Yes, a big, big increase. So here we are, all three of them, you know, nice straight lines. We got small, you know, fluctuations, which occur, again, is naturally for things to fluctuate. Small amounts, but then boom, straight up there. Huge increase. So, you know, if we look at example of just carbon dioxide, you know, if we're looking at what, 270, 275, and then boom, all the way up to almost 400. Big increase there. And what happened around 1800 and 1900? Think about a couple hundred years ago. What happened on Earth? What were people doing? What would cause this giant increase in greenhouse gases? Yeah, the Industrial Revolution. So we had this big boom in industry, factories, production. We were using energy. We were burning fossil fuels pretty noticeably. You know, we're thinking about coal and oil, pretty dirty, polluting type energy sources. And with that came those increases. So again, here's the evidence that scientists are looking at and saying, hey, look at this data. Look at the increase in gases. Okay? There's going to be an effect, and that's the increase in the greenhouse effect. Putting up all of those gases into the atmosphere, trapping that heat, it's going to make our Earth warmer, just like a greenhouse. Okay, a couple big points to highlight here in that unit. Some impacts of the greenhouse effect are an increase in ocean temperatures, melting polar ice caps, and an increase in temperature, or all of the above. So what do you think of the greenhouse? What does it do? What is an effect of it? I think that's A, B, C, D. I apologize, I need to like move off my screen. Great, thank you for sharing. Yep, it is D. All of those are impacts for the greenhouse effect. We see an increase in ocean temperatures, melting of the ice caps, increase in temperature. We also know that, again, the greenhouse effect is, you know, it's a natural occurring phenomenon on Earth. We want that greenhouse, we want that atmosphere to create that perfect balance. But as we can see, we are changing that balance by producing more and more greenhouse gases. And so with the human produced enhanced greenhouse effect, we get all of these effects. The burning of fossil fuels is thought to be the #1 cause for climate change. Is that true or false? So the burning of fossil fuels, again, are greenhouse gases. So as we think about, you know, driving more cars, carbon dioxide, methane, nitrous oxide. That is a true one. Yep, definitely so. It is thought to be the #1 cause, putting more of those gases into our atmosphere. Hand in hand, we trap it, we get warmer. Methane and carbon dioxide are 2 examples of greenhouse gases, elements, air, solvents. Yeah, you got it. It's greenhouse gases. Awesome. It totally makes sense. I know. The phenomenon where heat is trapped by the atmosphere is called radiation effect, global heating, greenhouse effect, or climate. Where heat is trapped by the atmosphere. What have we been talking about today? The greenhouse effect, that is C. Okay, greenhouse gases have decreased since the Industrial Revolution. We didn't go over that too much. This is one of the questions that I've seen in that Unit 4. And that is true. They are beginning to, we've seen a decrease in the greenhouse gases as humans are becoming more and more aware of what is happening. We're trying to kind of step back and reduce it. Again, we've still got lots and lots of room to go. And we also know that as population is increasing, our energy needs are more. And so you might hear people talking more about looking for better resources, natural resources that we can use for energy. Thinking about, cars. You might hear about hybrids, battery operated cars, solar cars. Humans are seeing that we're having this effect, and so we're looking for ways or taking actions to change it. Okay, that's what I have for talking about the greenhouse effect, which we first talked about, why the sun is important to us, what we get from the sun, how we can't survive without the sun, and then thinking about the earth and this natural greenhouse that we have, which is good. We have that protection layer of our atmosphere. And then we talked about how, some of the things that humans are doing, our actions are causing the earth to get warmer. More gases are being produced into that atmosphere, trapping it down. Less is getting out. Can I get my words out here, right? You get what I'm saying. We're putting more of those greenhouse gases into our atmosphere. Therefore, it's trapping more of that sun's energy, making our temperatures warmer. Less is escaping. And so we're taking this out of balance. And we talk a lot about this in science, these systems on Earth and how they can get out of balance. And when they get out of balance, they have a negative effect, or they affect differently. As we saw, our polar ice caps and our glaciers are melting, causing increases in those ocean levels, which has more effects on our weather and major storms, also biodiversity and habitats for organisms that live here. Okay, so thinking about human actions and what we're doing in trying to kind of lessen our impact, or you might hear them say like lessen our footprint on the earth, is kind of where we're looking to go. So hopefully, just thinking about these topics makes you aware. And I know they're pretty prominent. We hear about it in the news lately, a lot more so. Hopefully it makes you think about, okay, what can we do? What am I personally doing? How can I help? How can I limit my impact? Okay, great. Okay, so that's what I have about ozone layer and the greenhouse effect. How about you guys? Do you have questions for me? It could be on this. It's a pretty interesting topic. I know there's lots of things going on. Or do you have a question about a topic that you're working on or an activity? Again, you're welcome to unmute yourself and just talk out loud. You can use that chat and you can type in if you've got questions. I'm going to give you a moment. I know sometimes when I'm on video conferencing or sessions like this, and I'm typing in the chat box and I'm like, don't move on yet, I'm still typing. So I'll give you a chance. Again, we will come back at the end of the session and I'll open it up for more questions as well. But we'll first start off here. If there's something plugging in on your mind. Okay, yes, then we'll come back to questions and I'll go ahead and move on to a little bit more on science. I wanted to talk about scientific investigations, right? So as we think about the purpose of science, what do you guys think about when you think of science? Why do we have science? Why do we practice science? Why is science important? What comes to your mind? Hopefully all good things. And hopefully you're not like, oh man, things I know nothing about. Hard stuff. We use science in our daily lives so much. And science continues to make our world better. Thanks for chiming in. Yes, figuring out how things work. Exactly. Figuring out how things work. Answering questions that we might have. Maybe trying to make our lives better, the world better. Those are all things that scientists work on and do. So kind of the idea behind science is to answer questions that we have. And to do that, scientists use investigations, scientific investigations. So you might have heard of the scientific method. It's a way that kind of the steps that scientists go through to, test something out to find the answer to it. Okay, so when conducting a scientific investigation, these are the steps to complete to ensure our biggest thing is accuracy. Sometimes you'll see in big in news headlines, be like, somebody says they found the cure to, and again, the question is, well, where's your evidence, and how did you find this information out? So we want to make sure that things are accurate. That means that, there's no other kind of outlying means that could change, or I use the word skew a lot, kind of make the data wrong or inaccurate, so to speak. Okay. And I like talking about scientific investigations. And in the courses you'll see in science, we have in biology and earth science, and also in a couple of the grad point courses, there's some investigations kind of built in. You might see me doing a couple of videos in there, or I might ask you guys to kind of carry out these steps or write up a question. Or you might be doing in grad point, I know in like physical science, you do a couple little investigations there, looking at kind of the laws of gravity. I remember I'm thinking of one I was looking at today when I was grading. And I like to talk about it here in these types of in a forum, because we know kind of like in our online sessions, sometimes we don't get that whole on like in a lab type experiment, but as we can see, we can still complete investigations. We can still have a lab, even if it's at home, okay? So I like to show kind of how that works a bit more. And there are these nice little steps that we go through again to ensure that accuracy. And so when we think about the scientific method, we always start off with a question, okay? What are we trying to figure out? What are you trying to answer? And when we think about a question, it has to be something that is testable. How does sunlight affect plant growth? So you got to think of, can we test this instead of saying the good old question, why is the sky blue? How do we test that? Okay, so it has to be a testable type question. And then we always come up with a hypothesis. We heard this word lots of times. Hypothesis. Anybody know what that means? If you hypothesize, what are you doing? Yeah, you got it. You're taking a guess. You're taking an educated guess, right? So a hypothesis, it asks us to think about that topic of the question and kind of activate our background knowledge. What do we already know about it? What have we seen? What do we kind of assume? And we make an educated guess about what we think is going to happen. It kind of helps guide our investigation. From here, you're going to gather up your materials, kind of set up the investigation by writing up a procedure, a very accurate, detailed procedure about what you're going to be doing. And in our procedure, we always want to make sure that we have, you want to write it so that you could give it to somebody else and they could recorrect it. So if you think about like a recipe, if you're cooking, and you're making chocolate chip cookies and you're like, okay, it says, pour in flour. Okay, well, you're probably in your mind, you're like, am I using like a lot of flour or a little bit of flour? So in our procedure, in the scientific method, we always want to make sure that we're as detailed as possible by using measurements and quantities and time frames. So instead of flour, we would want to say a cup of flour, right? Give more detail in that. We also want to make sure we're as detailed as possible as we're thinking about creating this again. Again, if you were to complete an investigation and you thought the results were really great and you wanted to share it with somebody else, or another scientist wanted to be like, I want to test this out myself, you would want to make sure that your procedure was as detailed so that they could, again, create it the same way that you did it. During that gathering materials, kind of setting it up, we have to think about how we're going to collect our data. And we can do it by collecting data, say, by our observations, or we can collect data, maybe it's based off of a number or a time. You know, how many feet did the ball drop? We can measure the height. We can measure time as we're thinking about, you know, how long did it take for the ice cube to dissolve or melt. Okay, while we then conduct that investigation, again, after we have everything set up, we gather that data at the same time that we're conducting that investigation. So as you're conducting it, you're testing it, you're writing down your results. Why? Because we want it to be accurate. Okay, after you're done, you analyze your results. How do we analyze our results? We look at the data that we collected. You know, based off that data table, you can take, maybe you have a bunch of times and you have multiple trials to ensure consistency, because, you know, you've got to do it at least 3 times to make sure that it's accurate and not just kind of a fluke. You're going to want to, you can take averages and average things out. Yeah, exactly. Stats, collecting that information so that we can then look at, you know, the other types of changes, what we call them variables, and see how they were different or how they were the same. After you analyze those results, you get to write this conclusion. Again, this is a very, very short form that I'm just doing here, going over the steps. And when we think about, well, what's a conclusion? The conclusion is the answer to this question. So in your conclusion, you actually go back and answer your question, but you can answer it because you have evidence from your data. So your data is what is your evidence. It helps kind of prove the point of your question. How do you know this? You know? Okay, let's see. So in our science, in semester 2, in lesson 4.2, so in that unit 4, kind of what we've been talking about it, I did an investigation on the greenhouse effect. Now, of course, did I get to go up into space and do this? No. I did it in my kitchen. And what I did is I made a model of kind of greenhouses. Okay, so if you haven't seen that, you can check that out in our science semester 2, right there. But what I did is I recreated it. So again, I created a model to test this out and collect data on. And what I did is I set up, you know, my energy source. I used a heat lamp or a lamp to act as my sun. And then I collected some variables. So I wanted to see, you know, how does the environment or a covering affect, how does the greenhouse affect temperatures? And what I did is for kind of my planets or my atmosphere here is I took 2 jars and I wrote up a procedure that was nice and detailed. You know, I collected things that were, I used what we call constants and controls, making sure it was consistent. So I used 2 jars that were exactly the same size, same brand. And I took one and I put saran wrap over it. So I made a covering acting like our atmosphere, like the greenhouse. And then my other one was empty. So we call these the manipulated variable. It's what we're changing to see the effects. I manipulated a jar and I put kind of a lid on it, and I left one open so I could compare the 2. And then I took temperature readings. So I took like an initial temperature reading before I started this to see what it was, what was the temperature. And then from there, I would do intervals, say like every 5 minutes, I would come and check the temperature on this. And I had thermometers inside the jar, so I didn't have to open up my atmosphere. It was trapped in there, really trapping that heat. And then in the end, you know, I collected all that data and then I got to kind of analyze it to see what happened. Okay. So again, this kind of goes into the version of, you know, how do different environments affect temperature? This is what I what I was showing in that video. And for my hypothesis, what I said is if I had different environments, or like I said, coverings, making a model here, then the jar that is covered will have a higher temperature because heat is being trapped, okay? You know, I base that from what I know. You can think about like when you're in a car, it's warm outside and you go into a car that the windows are shut, the doors are shut, and you get inside, it's warm in there, right? Warmer than outside. It's trapping that heat. So we kind of see this happening in these mini little greenhouses. You can see I gathered up my materials. So when we write up investigations, we have this whole kind of lab write-up or lab report, and it includes each one of these steps, making sure, again, it's adding to that accuracy. There's my temperature. Again, I made sure in my details, you know, I talk about the temperature should be the same for your starting temperature. Talked about making sure the lamp was turned on. Recorded each jar, gave you the intervals in there. So again, I'm adding details to this. So you guys could do this as well. Going back to those variables, these are pretty big items, concepts that we like to think that we use in science. So in investigations, we have the manipulated variable, what we change to see its effect. Covering, no covering in those jars. The responding variable is what is measured based on that change. So the responding variable is based off of this one, what we changed. So what are we measuring? Temperature. Was there a change because of that covering? Controlled variable is what's unchanged or used as a comparison. Sometimes I like to, an easy one to think about, if you're testing, maybe you're doing an investigation on temperatures, like water temperatures. And if you think about it, if you have your manipulated variable, you have a hot water, you have a cold water. Well, a controlled one would be, you know, maybe room temperature water. So you're not adding heat to it, you're not taking heat away from it. So it's like right in the middle. So you can see something that's higher and see something that's lower. It's a nice comparison. Okay. And then as you perform your experiment, you collect your data through a table. And again, a table is a nice visual way to see that information. We, of course, use units of measurement, so degrees Celsius and times. We use labels. Okay. Oh, yeah. And this one I did 3 different ones: uncovered, covered with holes, and then completely covered. Okay. In the end, I took an average so that we could see kind of the changes that occurred. From here, we then write a conclusion. You know, you go back to that question. Was my hypothesis right or wrong? Using your data, my hypothesis was correct. The covered environment had the highest temperature. I kind of bulleted out here. I'm gonna make that a little bit more prominent. The major parts to include in that conclusion. Was your hypothesis right or wrong? What was your data range, your evidence? And then that concluding statement, final statement with evidence, okay? So then I gave the data range for each one of my environments, and I used the average, and then my concluding statement. The type of environment does affect the temperature. The covered environment was the warmest and had an increase of 2.5 degrees more than the covered with holes. Oops, sorry guys. And 4.5 degrees Celsius more than the uncovered. So I'm not just saying, yes, it has an effect on temperature. I'm showing you what the effect is. So I'm providing you with that evidence. I'm backing up my idea with this data that acts as an evidence. See, it's saying, yes, this happened. I took temperature readings and this is what it is, okay? So that's the importance of that data, that evidence. It backs up your conclusion, okay? You can't just say, yes, it worked. You have to explain why it worked or how you know it worked. And that comes from the data that you use, okay? It's so much more powerful to say, look at my numbers. Look at, these 3 different environments. My covered one was, 4.5 degrees warmer than my uncovered. So yes, the greenhouse has an effect on temperature. It's warmer, 4.5 degrees warmer. Okay. Hopefully, investigations are pretty cool. Again, I like to kind of every once in a while in these live sessions, I like to go through another one because, again, I do want to give you guys the type of the lab experience that we can have in showing you investigations and how we can complete them without actually being in a true lab, even though our kitchens are labs themselves. Okay. Thinking forward as we think about, well, why is it important to do investigations? Like we said, to see how things work, to answer questions that we have. To do that, we have to test and we have to have evidence to support our ideas. And that's what we do with investigations. So these are happening every day of our lives. Scientists are investigating and they're running tests. You see it all the time, with medications. You'll hear about case studies that they're doing. So this is something that's happening all the time. Okay. Does anybody have any questions on investigations? Okay. Before we leave you today, again, I want to open it up for questions that you might have about your particular course, where you're at, or maybe you have a random question about something that I brought to your attention today, or an idea that came to your mind. Science always does that. It brings out more questions that we have. You have a question about an assignment or an activity that you're looking at, please go ahead and share. You can unmute yourself. You can use that chat. I'm going to go ahead and keep talking, but please interrupt me if you have questions. Okay, I just want to use everybody's time. Here we go. Oh, no, thank you for joining. It's so nice to have nice little group here where we can interact with each other and remember that we are all, in this together. Our teachers, we're here to help support you guys. Your teachers are all learning at the same time too. You can tell I like science. I hope you guys enjoy science as well, but it's fun to come back into this kind of classroom environment and see that we're all in together. Okay, going off of that, maybe, right now you're just so excited about the greenhouse effect. You've got it down. Your mind's maybe pulling a little blank about where you're at or what the question was that you had, but moving forward, please always remember that you have this nice community of support here with Graduation Alliance, and thinking about if you have questions, always reach out to your teachers. Never get to that point where you're so frustrated. No, send us a chat, send us an email, please. Sometimes it just, having somebody else explain it just in a different way makes all the difference in understanding that concept. And so if you have a question about something or you're not sure what to do, please just reach out. I'll get back to you as soon as I can. Same with all your teachers. We're here to help you guys, support you guys, and help you get to your goals. So please always remember that. Ask questions if you need to. We can also, give you guys more resources. If you're interested even in a topic, if you've got more curiosity about it, I can send you some places, some cool places to check out, especially with science. And again, you do have this nice collection of this library at these live sessions. So as you're moving through your courses, you can always go to that library and come back and be like, I wonder if they did something on the water cycle. Let me go look. And you'll find a live session about the water cycle to get a little bit more information about that. Okay. Thinking ahead during these live sessions, I always ask students, hey, you got an idea for a live session? If you want to see me do something, you have an idea for a topic, or you're thinking, oh, hey, next week I'm going to be here, let me know. And I can plan a live session to kind of help tailor fit your needs. Would be great. Okay, keep checking that dashboard for the schedules. And again, I like to say keep an eye on, what sessions are coming up, and then maybe kind of ask yourself, when you get that notification, do I have any, questions beforehand? And of course, you can pre-write your questions out if you want to, and you can copy and paste it right into that chat message for the next time there's a session. Just an idea, whatever may help. Okay, well, I hope you guys enjoy learning a little bit more about the greenhouse effect and a little example of a scientific investigation. Okay, I'm gonna sign off for today. Everybody have a great day and a great week in science, and get those assignments in, communicate if you need some help, and good luck, and everybody have a great day. We'll see you next time.